Hi Lakshmi. Hi Sidhu. How are you? Actually, sorry for delay. I was facing some problems, so that's why it it's 5 minutes late. Okay. Hello. So, very good evening, Aditya. Very good evening, Harish. Yeah, I'm waiting for you only. Okay, till then everyone join. Let me just explain your doubt, right? Very good evening, Niharika. Yeah, I'm taking. Not worry about this. Okay. So you ask about the doubt in hydroboration reaction, right? Okay, so listen that what is the meaning of hydroboration, or like what is the problem maybe you're facing? Hydroboration reaction. So in hydroboration reaction, we are using first of all the BH3, okay? The reagent, if we are talking about a reagent, so how about the reagent? We are going to use the BH3, okay? BH3 in the solvent that is THF. Okay, so this is the reagent first of all. And one more reagent along with this, we are going to use NaOH or H2O2. You can use any peroxide reagent like the H2O2 there. I hope you know what is H2O2. It's a hydrogen peroxide simply. Okay, so these are the reagent we are going to use. And what is the main agenda, like how the reaction is really following the thing. So you are having a carbon-carbon double bond simply. Okay, and in this, I'm using this BH3 and then THF, and the second one we are going to use that NaOH and that H2O2 there. So this is a simple, and in this reaction we have to start with the 3 mole of alkane, okay, and the BH3 is able to convert the 3 mole of alkane into the 3 alcohol is there, okay, like this let's say. Okay, so it's a 3 mole there, and in this reaction we are going to follow the anti of Markovnikov of addition there. So in this one we are going to follow that anti Markovnikov of addition, okay, anti Markovnikov of addition. Now the question, like how to proceed with the mechanism, like maybe you're having a problem with the mechanism, so let me just explain the mechanism part to you. So basically we are having a asymmetric alkene or unsymmetrical alkene, you can say that it's a CH2 and a double bond and a CH2 there, right? So this is a simple unsymmetrical alkene there. Okay, so since in this case we are going to follow the anti-Markovnikov addition, okay, it's anti-Markovnikov addition. So obviously that what we are doing, that preparation of alcohol we are doing, right? So means what is the product? Like how about the product we are getting in this reaction? That you will be having some CH3 and a CH2 and this OH group simply connected here. Okay, so this is simply that what we want. Okay, this is the meaning of anti-Markovnikov addition. But how about the mechanism? So let's record the mechanism. First question from this topic, that if I'm using BH3, then what is the use of this THF? So THF is what? THF is tetrahydrofuran. This is THF structure. And what is the use of this THF? This is nothing. This is just behaving like a solvent. Okay, then what is so special about the solvent? Because as we know, this is famous for the banana bonding. There is a B2H6 that banana bond formation take place, and it is really very difficult for us to stop the BH3 in this structure only. So THF be like, not an issue, BH3 you are having a vacancy, I will help you. So the lone pair simply transfer here. So this is the main agenda of using this solvent, just to stabilize the structure of BH3. Okay, so this is a point number one. Now the point number two, that like how to follow the mechanism. So in this case we are going to follow the syn mechanism. So what is the meaning of syn mechanism? It means that attack from the same side. So let's just talk about the mechanism part, like how to proceed with the mechanism simply. Okay, so let's just discuss about the mechanism part here. So you are having some carbon, double bond carbon. Let me just write, like it's asymmetrical, right? So it's this is how it's look like. Okay, like this. And let me just write the BH3 be like this. Okay, Harish. So observe this, that this is a vacant. Okay, this is a vacant. So the carbon double bond simply attack here and this hydrogen simply attack here. Okay, it means both are adding from the same side. So which kind of transition state we are end up there? This is my CH3. Okay, and one more carbon. You can say this hydrogen simply connected here. This double bond is about to break and this B is simply connected here. Okay, and okay, these are the solid bond. This is simply that it's a four-member transition state take place there. And let me just write that it's a CH2 and this side hydrogen. Okay, wait, it's not correct. That one hydrogen like this and second hydrogen like this. Okay, so it's simply hydrogen. Okay, then. So that's why in this case we are going to follow the syn mechanism, that both the B and H attacking from the same side. Okay, let's see actually what is going to happen. After this, what is the final product we are getting? That you are having a carbon. Okay, it's a CH3 and it is a CH on which the hydrogen part connected. Okay, I'm referring this carbon here. Okay, and the second one, this carbon is now connected with BH2 molecule. Okay, and a two hydrogen like this. Now, in this case, we are having a scope. Boron still have two hydrogen. It means boron further combined with three molecule like this. Okay, this is the first compound that is the already connected. Now the two more hydrogen follow the same mechanism and replaced by the two more alkane. So let me just write the final structure, that if this is a boron, it is connected with some CH2, CH2 and CH3. Okay, it is some CH2, CH2 and CH3. Okay, this is my CH2, CH2 and CH3. Okay, is this point clear, Harish, that you're facing there, right? Like how that it's connected with three things. Okay, this is a step number one. That simply that addition of alkene to the boron there. Okay, now the second step, although it's not important, mechanism is not really very much important there. Okay, be noted, I'm just explaining only. So the second step is what, that in this case we are using NaOH. If you remember, the second step is the NaOH and H2O2 there. So what does actually how the mechanism look like for this NaOH and H2 there? So listen, NaOH is a base. Let me just write in the corner like actually really what is happening. NaOH is a base. Okay, and this is my hydrogen peroxide like this. Okay, so OH be like give me one hydrogen. Okay, so basically this NaOH abstract this hydrogen there. So basically we are end up with O and H. So this is the thing which is really going to attack on a boron now. Okay, so let's see the next step is what, that you are having O and H, and this O negative now simply attack on a boron. Okay, let me just move to the next slide, like how the mechanism will look further. So you are having B. Okay, I'm not representing now, so B noted, these are alkene group is connected and this is O and H. Okay, second of what, that this bond simply substitute. Okay, so in this case the bond is going to break. How the bond breaking, that you can say this bond simply attack here. Okay, so it's like concerted mechanism if you don't know. So we are what we are getting, that this is a this bond simply connected here, it is connected with oxygen. See the conditions which, like let me just write 1 and 2. So now the bond between this bond simply break. Okay, let's just write one more carbon. Okay, so this bond between boron and this alkene break, and this is now forming a new bond with the oxygen like this. Okay, and boron it keep connecting with two more group like this, and then this is OH group simply. Okay, similarly, that if you have to go further, these two group is also replaced by the O, so we are getting that B O wait, BO like this and BO like this and BO like this. Okay, and then again the OH came in, the H positive came in, sorry, not OH is going into, okay. So now next one is what, OH again come into the picture because NH is available. So this is how the bond break and then bond break. So what we are getting, that we are end up with three molecule of alcohol and plus the boron is combined with three OH. So we are getting H3BO3, that is boric acid. Okay, so I hope now the mechanism is clear, that how actually it is going to follow. Or simple, it is able to replace three alcohol. Okay, sorry, it's able to replace three kind of alkyl halide. Okay, Harish, are you getting my point? Very good, Tarun. Yes, please, Harish. So you can skip the last step, okay? I know it's very difficult. That's why in the previous class I'm not I not explained this thing to you there, right? So just simply that understand the concept what is really happening, four member ring simply, okay? And it is simply connected with three double bond system because boron has three hydrogen. And then this is the next step we are going to follow and we are end up with the final result. Now the problem is I guess in the question. So what was the question in the previous class? This is a question basically, right? This is a question. So in this question that we are given with BD3. Simply this we are given there, right? And in this case that now we have to decide we are going to simply follow the anti of Marconic addition. It means in this molecule I am end up with like okay this is the case and BH instead in place of BH we are having BD3. So you can say this D's group is connected here. Let's suppose if I'm considering the CH3 be like at that dash position, so it's going to be the wedge position there, okay? So again if this is D there and still this BD are this B D2 connected here, and if you to add the NaOH and H2O2, you know the OH part is from H2O2 or NaOH side. Okay, so that's why what we are getting there that simply if this is a five member ring and if it is connected with at the wedge position, so my D is the desk position and this is also the desk position. Hence, this is a correct answer for that question. Yes, Aris, any problem still left? What is your doubt? Done a question and why don't you neglect the option will be at the first? Okay, because their stereochemistry is not mentioned. Okay, Harish, that's why we are not considering that option. Okay, you know like what is the use of this BD3? They just want to check like whether you know the mechanism or not. Okay, so stereochemistry is important. Important is what we are going to follow the syn mechanism. That's why I'm explaining this question to you, Harish. I hope you are getting now actually what is this, right? Okay then, so let's continue with the today's class, okay? Okay then, so in today's class we're going to start with the new mechanism. Let me just check what will be the next reaction. Okay, so the next preparation, we already covered the two preparation, acid catalytic reduction, that the first part. Let me just quickly give you a brief. We are discussing about if you are having a carbon carbon double bond, so basically how to convert into the form of alcohol there. So the step sorry, the reaction number one we covered acidic catalytic hydrogenation there we're discussing about the acidation of water and Marconic addition, that part. Okay, and the second of what that hydroboration. Now the third we are going to discuss in today's class, that oxymercuration and demercuration. Okay, again, like mechanism is not really important here. What is the important here? That try to understand the concept. Let me first write, then I will explain like what is so special about the oxymercuration and demercuration. So what is the name of the reaction? That oxy. Okay, as the name suggests, something is connected with the oxygen addition. Oxymercuration and demercuration. Okay, so I hope you know the meaning of that dehydration, dehallucination means D means removal. So in this case, that oxy represent addition and represent removal. Okay, so it means that in one part we are going to discuss about addition of the mercury and the second one that is the removal of the mercury. So let me just write the general reaction and then again we are going to discuss about like what about the consequences or why we are using this reaction. Okay, so what is the general reaction that you will be having again? It's a CH3. Make a kind of knot where we are going to follow the Marconic of addition and where we are going to follow the anti-Marconic. So again, just write in a bracket that in this case we are going to follow again that is a Marconic of addition. Okay, Marconic of addition again we are going to follow here. It means that what is the reagent we are going to use here, that you will be using AHZ. Obviously the name of the reaction is oxymercuration demercuration and it's nothing, it's a OAC. I will explain this thing as well, just wait for a while. And this and water and THF. Okay, so it's a water and THF, so everything is just in a one single step, they are the solvent only. Okay, this is one arrow. And the second step is going to be the NaBH4. Okay, again, make a kind of chart for the reagent as well. This is famous reducing agent. Okay, this is nothing. It's a really famous one. That is a reducing agent. Like the KMNO4 and K2CR27, we are having lithium aluminum hydride and the sodium borohydride are the two important reducing agent. Okay, so that's it. Now, since we are going to follow that, in this case, mercuration. So, how about the last product, CH, and the OH group is simply connected here, and it's a CH3. Okay, done. Now, my question to you. Okay, this is all for the reactions. That much sorted, oxymercuration, demercuration. Yes, just hold on a second. I will explain the mechanism. But my first question to you, that in the previous class we discussed about the acidic addition, if you remember, diluted acid or diluted water we are using, right? Along with the acid, like diluted acid also there. And see, why not we can simple do that reaction? Why we are doing this much kind of drama? Like what is so special about the reagent there? Do you know the reason behind this? That why not direct water addition? Yeah, we discuss about this one step, and this can be the third kind of reaction. But again, what is the requirement of this reaction? This is my question. Very good evening, Meera. From disonium salt, no, that part is for the what we're talking, that cyclic one. Okay, weak reducing agent. Hello, Vishek. I miss your chat, I'm sorry. Yes, please answer this question. Why we're using AHZOAC? No rearrangement possible. Yeah, basically you're right that actually this is the biggest reason behind this. We are using HZ because in this case the scope of the rearrangement is not there. Point number one. The use of HZ is what? In this case we are not getting any kind of rearranged product. Point number one. Okay, now you will tell me, Darshana, why no rearrangement is possible? If you know, then do you know the reason that why no rearrangement is there? Or let's just recall some 11th class topic. Okay, then this topic will be very clear for you. For example, my question first of all for you, that if you are having a carbon-carbon triple bond in sort its alkyne system, or a carbon-carbon double bond. So which one is more electron rich? Yes, please. If we are going to follow the electrophilic addition, so where it is going to add? Like a carbon-carbon triple bond or a carbon-carbon double bond? It's 11th class hydrocarbon topic, if you know. Don't know. Okay, not an issue, Darshan. I will explain, okay? Ethyne, triple bond. Okay, let me just give you a kind of hint. Okay, let's just suppose in both the cases, I'm adding water. Okay, simply water. So in this case, what we are end up basically that first of all, the its attack on H positive, and let's suppose this is some hydrogen and this is a positively charged like this. Okay, and in this case, we are getting simply that is this hydrogen is connecting. Okay, this is like this step. I'm explaining simply this. And the same question again, in which case we are getting a stable intermediate, and then you will get your answer correctly. Which one is more stable here? A or B? Which double bond, positive charge is more stable? Yes, please. A, B. Okay, come on. I guess your juice is really very weak, you know? A is what? sp2 hybridized electronegativity. Right, Harish? No, 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 no. What are you doing? Listen, that we discussed this thing so many times. That is a percentage as character is directly proportional to the electronegativity, right? And it's directly proportional to the minus I effect. And we know very well that positive charge is deficient, you can say intermediate. Then how it is possible for a positive charge to stabilize with a double bond? No, I guess you don't know, but a double bond directly on a triple bonded carbon or a double bonded carbon is really really unstable. Okay, carbic 10, this kind of carbic 10 is really really unstable. Okay, you're not saying the answer. Oh, oh. Then what do you want to say then? Okay, so I guess you are getting my question. Yes, technically triple bond is more electron rich, but it's not going to participate. Who's going to participate first? That is a double bond. Double bond is going to participate, not a triple bond. Okay, the funda is clear because the carbocation that is directly present on a double bond is not stable carbocation. Okay, like if let's suppose we are going to discuss about a kind of diagram as well. So how it does look like that? Okay, like let's suppose we are starting from Reactant, okay? That let's suppose this is a carbon carbon triple bond, and this is a carbon carbon double bond like this, okay? And both are reactant side, okay? So for this graph, the graph look like this, and for the triple bond, the graph look like this. Okay, see this, see the difference here. That why? Because see, in this case, if we are talking about an intermediate there, so it's a double bond and a positive charge like this, so it's unstable. Unstable means if you want to form something unstable, so obviously that step is requiring huge amount of energy, or the rate of the reaction is very slow. Look at this activation energy. Okay, this side we are having a potential energy, and this is the same reaction coordinate. But on the other hand, for the pink one, that we are getting a stable carbocation, because it's a simply that is sp3 there. Hence, in this case, if you to observe, the activation energy is not that much high. That this is the yellow one. Okay, so this is the diagram as well, and it's a part of 11th class hydrocarbon. If you don't know, it means if we are having a choice between a double and a triple bond, we are going to follow the double bond first, then triple bond first. But yes, if like let's suppose there's a tie, then we can go with the triple bond. For example, like this is a question for you. Okay, try to answer the question. If you are having a carbon-carbon double bond and a carbon-carbon triple bond, I guess this is a PYQ, right? I'm not remembering, but yeah, it's something. Some this question we already discussed. I guess in 11th, I don't know which class. Okay, it's H2 there. In this again, I'm using only 1 mole. Okay, listen my question that I'm using 1 mole of HBr. Okay, 1 mole of HBr. So you will answer the question like what will be the possible product for this question. Okay, that option number one. Okay, this is option number one. Option number two. Okay, it's a very good question. Just take your time, then answer the question, please. Okay, and D. I have to read the option number D here. Okay, yes, please. Which was the correct answer here? CS3. Not CH2. Okay. Oh yeah, I'm sorry. Wait, I will change this. It's CH3. Okay. Just pardon for my silly mistakes. Okay, then answer please. Which was the correct answer here? Okay, then, Darshana, everyone answer this question. It's really interesting question. A, okay. I want this, okay? I want that everyone have to answer the option number is the correct. Okay, because it's really interesting question. Are you sure that option A is going to be the correct answer? Okay. So like as I explained that if there's a preference, if you want to choose between the double and a triple, so you can go with the double. So definitely this is going to be the right answer, right? But let me tell you, the correct answer for this question is not A, actually the B. B is the right answer. Okay? Or, or that C can be the right answer, but not D. Not D, not A. Okay? So, like, what is the issue with this option? Because it's a anti-Marconic addition, so and it's out of the race. Okay, and yes, now between B and C, you have to decide. So same hint you can apply the anti-Marconic one. Okay, let me just explain. Okay, let's just not waste the time. Again, it's anti one, so it's not correct. So only the option C we are left. So C is the correct answer. But why? It's a simple common chemistry rule if you know the reason. No, C is the correct answer. But why? It's a common, simple organic chemistry rule, if you know the rule. Did you notice something here? Conjugation. You're having a two double bond and they are participating in a conjugation. So that's why I told you, if you're having a choice, yes, of course, it's allylic one. Okay, if you are having a choice that like aromaticity, allylic system, or a conjugated system. So yeah, you can omit the rule, we can violate the rule. Exception is everywhere. So listen that yeah, if you are having a choice between triple and double, you can go. But in this case, do you know why I'm not using extra carbon? And if I want that you have to answer the like this is the correct answer. No, what is the key point here? That in this case, after all the cases, that the plus point is what? That these two double bond in a conjugation. I hope you know single bond, double bond, single bond. This kind of conjugation we are getting. Okay, so sometime that exception can be there, or the reason is always what? Either aromaticity or conjugation, or something have to be there. Okay, something that try to lead the stability there. Okay. Okay, is this question clear or is the complete part clear? So now let's just again back to our HZ topic. Okay, so that's why I'm creating a kind of base so you are able to understand my point. So listen now, let's back again oxymercuration, demercuration. So what is the problem? If let's suppose we are having a carbon-carbon triple bond, okay, so first of all that you have to take on some H positive and then we are getting, okay, it's a carbon-carbon double bond and positive charge. So carbon will be like, no, I don't like that positive charge because it's really unstable. Then Mercury will like, okay, wait, I will help you. If you remember the same reaction of the 11th class, we are using some HgSO4 there. Then what is the use of this extra HgSO4 there? HgSO4 will like, if you to attack on me, I am forming a kind of cyclic bond there. And it's a partial positive. Issue sorted. What is the issue? Issue is what? That carbon not able to bear that positive charge directly. Now what the problem solved? Now let's suppose if some kind of OH group came into the picture, simply attack and bond upon it. Not even at a single step there's a formation of carbocation. So problem solved. So now let's just back again toward the oxymercuration and demercuration. Do you know why in this case there's a no rearrangement take place? Because Hz form a cyclic structure. Let me now explain the mechanism and this point will be clear for you that why we are selecting the Hz over the H2SO4. Okay, in which cases where we don't want any kind of rearrangement. So think about it. If you're using Hz, there's a cyclic state, there's a no carbocation. If no carbocation, then what is the rearrangement? So obviously the rearrangement is not going to take place. So now let's discuss about mechanism. Mechanism is super easy now. Okay. So first of all, it's going to be the addition of mercury. Okay, or you can see the step number one is what? That is mercuration simply. Oxymercuration. So the step number one is mercuration. Again, the mechanism is not important because it was a part of 11th class mechanism. Okay, in 12th class, it's not really important. If you want, you can skip. Just try to understand the topic. That's it. Okay, so the step number one, it's a oxymercuration. So oxymercuration is nothing that in the bracket, let me just write that addition of mercury or add if you're adding mercury there. So addition of mercury is simply the oxymercuration. So let's see actually what is happening. Oh, one more thing, that what is this Hz? HgOCOCH3. I guess everyone you know what is OAC, acetic acid kind of thing. It's an acetic group, acetic acid or acetic anhydride. Every time we are using this so many times. Or one more OC. Okay, if you remember these kind of thing we already use in a salt analysis, if you remember our regular classes, right? So in short, this Hz achieve a two positive charge. Okay, it means just because of this now Hz is two positively charged ion. Okay, this is partial positive, you can simply say. So what is really happening, that you will be having a carbon carbon double bond. Okay, let's just write again, this is a CH3. Okay, it's a CH and it's a CH2 there. Okay, so this double bond simply attacking here. Okay, so this double bond attack on Hz, this double bond attack on Hz. Okay, this bond break. Maybe you don't know, but OCH3 is a very good living group. It's a very good living group like the halocene family. Okay, so this is a step number one. The bond moving here and Hg simply attacking here like this. It's a cyclic kind of thing. It's moving, it's simply releasing there. So let me just write the step number two, what we are getting, that you will be having carbon carbon single bond, and it is a CH3, and this HZ connected at the very top. Okay, this is HZ. It's connected with the two carbon now, and this OAC will remain same, and one OAC release. Okay, OC negative, this part release. This is a step number one, addition of HZ. Okay, step number one, addition of HZ. Again, the mechanism is not important. I'm repeating again and again. Okay, just focus on like actually what is happening there. Step number one, addition of mercury. Okay, now again, what is this? It's a three-member cyclic transition state. So let me just write a positive charge on this, or better to write partial positive charge. Okay, it's a three-member. It's a simply three-member ring. And if you have to observe that not even a single carbon we are getting any kind of charge. No, we're not getting any kind of charge. Okay. Now the step number two. It's a step number one. And in the same one, okay, we have to proceed the further, the second step. So again, we are getting now, this is a carbon carbon, and this is Hz, and this O is simply connected here, and this is some CH3, and this is hydrogen. Now water, the H positive, because what we are doing, the addition of water. Okay, the only use of Hg just to make this state so that no positive charge on a carbon appear, and we are not able to get any kind of rearrangement here. Okay, so in this case, uh, if let's suppose I'm using a water, okay, so better to use simply water is there. So it's a water attack here, and this bond open up like that. So step number two, it's a CH3. Oh, water. Still the water is simply connected here. It's a positively charged ion. Okay, and it is a Hz. Maybe it looks scary. Okay, this is the real chemistry, organic chemistry. Okay, now that OC. Let me just again see this OC. This OAC that release in the step number one again come. So OAC be like, water, you are having extra H positive. Why not you can give me? Water be like, not an issue, you can take. Okay, so this is how the step is going to happen, and then what we are getting next one, that we will be getting, it's a CH3. Okay, this and OH is simply connected here. So the first step is done. Addition of mercury is done. First step is done. Okay, now the step number two, that removal of mercury. Step number one, simply that mercury added, it's a three-member ring there, again addition of water, and then this one we are getting right now. And please connect hydrogen, it's not an issue. Okay, step number two, that demercuration or removal of mercury, you can say. So step number one, addition. Step number two, that is a demercuration, removal of mercury. Okay, removal of Hz. Okay, so now let me just write again the same thing. It is a carbon, it's a CH3, OH, Hz, OAC. This is the simple case. And then again in the step number two, okay. So in the step number two, what is happening? This is going to release, okay? And we're getting H positive ion, and this simply attack here. So let me just write, it's a CH3 and OH group connected here, and this is a CH3, okay, like this, okay. And please connect, already there is a two hydrogen, it's not like it's not present there, I guess it's miss. Sorry, it's not CH3, hydrogen have to be there, otherwise then you will reach the problem how it's extra CH3, right? I'm sorry for this. So this is a correct answer. Sorted. Okay, first of all, what is happening? Addition of mercury. In a step number two, removal of mercury. Any issue with the mechanism? I'm not saying like you to remember the mechanism. Okay. Okay, Harish. I'm sorry for that. Okay. OAC. Is this point clear? Like I guess that doubt is clear for everyone. Abhishek, AUC part is clear, and Harish, that extra CUG is not have to be there. Okay. This is my problem. Okay. No, Harish, it's not important. Just be noted that what we are going to remember, hydroboration, anti-Marconic of addition, oxymercuration, demercuration is what? Marconic of addition. This is the only thing we are going to remember from this class or 12th class. Okay. Now, after this complete discussion, let's solve a question. Okay. Very easy, simple question. Try to answer the question. That's it. This is all for the mercuration part. So let me just write the question for you. Like actually, what is the like the use of this? This is a question, and it's a very chill question. Try to answer the question. This is a CH and this is a C double bond. It's a CH2. Okay, I know my H look like N, but sorry again. Look at this. It's a 1 HZOAC twice. And the second one is what? That NaBH4. Okay, I'm sorry, I just missed a point here. You know what? Where this H positive come from? This NaBH4. Okay, this NaBH4 is a reducing agent. Reducing agent means reduce other and itself oxidize. So what is the use that provide the hydrogen? So this H positive is really come from the NaBH4. Okay, be noted. I missed this point there. I'm sorry for this. Okay, now let's back again. So like this is A. Okay, there's some A form there. And this side we are using BH3, THF and H2O2 NaOH. This is some B. So you have to identify what is A and what is B. Okay, let me just write the options. Option number A. Okay, so A is equal to, it's a A. Okay, it's a B. So A is equal to CH3, COH and CH3. B is CH3, CH2, CH2 and OH. Okay. Option number B, CH3, CH and OH and CH3. Okay, if let's suppose I miss any hydrogen or carbon, sorry, carbon, so just connect. Okay. Or option number C, it's a CH3, CH2, CH2, CH3. And this is also CH3, CH2, CH2, OH. Or option number D, A is equal to CH3, CH2. Wait, I will change the position of my video. Just wait, okay? B is equal to CH3, C, OH and CH3. Yes, please answer the question. I hope it's not blocking your view now. Okay, yes. Answer the question, please. Okay. Okay, Lakshmi. Okay, Harish. Okay, Darshana. You're out of the blue, Abhishek. Every time different answer, huh? So you want to say option A or B? A, right? This is your name, Abhishek BX. Okay. They're from 12th P class. Hmm? D. Okay. Maybe you are right. Okay, maybe other are not right. Okay, D. Okay, so very good. Like actually the option number D is the correct here. Okay. So what we have to simply identify in this question. Okay, we are going to simply identify that how about the mechanism. So in this case we are going to follow the Marconic of addition. So according to the Marconic addition, where the OH group is going to connect on this carbon, so such this carbon or this option wrong. Okay, then in this one, in this case that we are going to follow the anti-Markov addition. It means that on this carbon, right? So such yeah, terminal one. So option D is the correct here. Okay, this is the only use of this oxymercuration and demercuration or that hydroboration part. I hope reaction is clear, I hope mechanism is clear, and I hope the question type is also clear. Okay, both reaction is super important. It's really, really important. Okay, that's it. Now let's see the fourth reaction, right? Fourth, what I can say, that fourth kind of preparation, I'm sorry. So from or by using oxidizing agent. No, wait. Oxidation. Wait, I will search. What was the fourth step? Using oxidizing agent. And please continue, like it is a preparation of alcohol from alkane by using oxidizing agent. Okay, this is the full statement. Okay, by using oxidizing agent. Okay, so in this case, that we are getting a two kind of reaction basically. That is, first of all, any oxidizing agent, any oxidizing agent. Yeah, Abhishek. This is the problem, This is the biggest reason behind the negative five deduction of the 5 marks, right? Yes, please. Any kind of oxidizing agent. At least let me know the famous one. KNO3, K2CR27. Again, you're different, Abhishek, right? I just pause like you are going to answer the KMNO4. Yeah, correct answer is KMNO4. Yeah, you can use K2CR27 as well, but K2CR27 is not that much strong like the KMNO4. So that's why we are using a basic the stronger one. There's just so many like and so many oxidizing. K-MnO4 can be there, K2CR2 can be there, HNO3 can be there, okay, or copper can be there. Yeah, you're right. Or Mn2O3 can be there. John's reason, so many reasons we know, right? But we are going to use the basic one. Like we are not requiring that much kind of uh, strong reaction here. So in this part, we are going to discuss about the two kind of reagent. The reagent number one, KMnO4. Okay, the reagent number one that is from KMnO4. And which condition we are going to prefer here? That is basic condition. KMnO4 and OH. I hope you know in acidic condition the KMnO4 is the strongest oxidizing agent. But we are using alkaline or weakly alkaline condition, you can say. Okay, and under cold condition. I hope this point or this statement make this point very clear, that why I use the cold condition, because we want the KMnO4 is not being like a very strong oxidizing agent. Or the second one is what? From osmium oxide, okay, that is OSO4. It's like KMnO4, okay, same like the KMnO4. And in the presence of NaHSO4, that is sodium thiosulfate, sorry, sodium bisulfate or sodium hydrogen sulfate, you can say. And the water is there. So these two reagent we are going to follow. So both are ditto, like same mechanism they are going to follow. So let's just start with the KMnO4. The first of all, so you will be having a carbon carbon double bond, okay, like this. And in this case, you can use both the reagent. KMnO4 and this part. You can use KMnO4, and again I'm repeating again and again, it's a basic condition, okay. And then osmium oxide is there, and you can write this is as a water. Okay, in both the cases, that what we are getting simply that diol formation. Okay, that at both the carbon there is a OH group is connected. Okay, it's important that we are getting which kind of alkyl formation. Options are vinyl, allyl, geminal. Which kind of alcohol these are? Yeah, you're right, Darshana. It's a Bayer reagent. Okay, in organic chemistry, this reagent we are going to check it whether the unsaturation is there or an organic compound or not, right, Darshana? You're right, it's a Bayer reagent. Yes, please. Okay, I'm not mentioning any R. Then how you are saying it's a glycol? Okay, glycol is only when it's like okay, the two carbon and like ethene is connected, right? Jamanal, very good. Okay. So, okay, okay, okay. What is the real meaning of geminal? Hmm? Come on, it's a very basic thing. We discussed just in the I guess very first part of the class. If both the OH group is connected here, so it's become geminal position, right? I guess it's not visible, so let me just write here, okay? So it's a C and a OH and OH. So it's a geminal condition, right? And in both the carbon, so what does it? Darshana. Hmm? No, what is it? Is it geminal or vicinal? It's a vicinal position. You know, this so many times we discuss geminal diol, vicinal diol, okay? So it's a vicinal position, vicinal diol we are getting. Okay? Adjacent carbon has the same group. No, 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 no. It's not like that, okay? That if adjacent has OH, so it's vicinal. If on a same carbon, it becomes geminal. Okay, Darshana. So it's not, we are not going to decide same carbon, different carbon. No, it's not the type, what, like you can say topic here. Okay, this is the point number one. We are getting that is a vicinal diol. Okay, that's it. Now the second point, in both the cases, we are going to follow that is a syn addition. This is important. I am repeating again that we are going to follow the syn addition in both the cases. Means if let's suppose this OH is above the plane, so the second OH is also above the plane. Or maybe that both OH is below the plane. So key point is what? That in this case we are going to follow the syn addition. Okay, not NT. This is the point number two. Okay, that's it. Now let's continue further. Now let's just talk about the mechanism as well. Okay, again the mechanism may be not in your syllabus. Okay, but let me just explain actually how the mechanism look like. So you will be having a carbon-carbon double bond, and please be noted you can connect any carbon, okay? Any R can be there simply. Okay, first of all, that you are using OSO4 and that are NaHSO4. You can use pyridine as well, okay? It's not fixed, you can use pyridine as well, you know? PY. What is pyridine? This is pyridine, okay? Like this is the pyridine molecule. So actually what is happening, this is like ASO4 there. So let me just write the structure. It's a osmium connected with 4 oxygen like this. Okay, so what was happening then? Let's just discuss about this. So this is attack there. Okay, this bond simply attack here and this bond simply attack here. So this is a like a cyclic kind of ring formation take place. Okay, so let me just write that what we are going to get now. Carbon carbon, this bond break. Okay, this oxygen connected here, this oxygen connected here, and then oh wait, then this is osmium OS. Okay, and double bond and a double bond. Again, just try to understand the mechanism. Which thing we are going to remember? Simply that from which side it attacking. Same side. Okay, so means what is the point to be noted? That both the which connected at the same side. Okay, what if that both are attacking above the plane? So let me just write it's be like that, like this. Okay, maybe it is attacking above the plane like this. Okay, because same side addition. So that's why the name of the addition is what? Syn addition. Okay, syn addition. Or uh, and then further, this is a step number one basically. And in this one, if you have to add that NaHSO4, SO4, okay. So simple that we are getting a carbon-carbon bond and which group is connected. Again, you can consider below the plane. Okay, it's not an issue. Okay, this is how they are connecting. Same, you can go with the K-4. Okay, like as we know, what is K-4? K-4 MnO4 negative, right? So again, you will be having some carbon-carbon double bond like this. And let me just write Mn, double bond, O negative, double bond. Same mechanism. It is attacking here, this is attacking here, this bond attacking here. So what we're getting again, carbon, carbon, maybe that both the OH is connected from the same side, O, O, Mn, O negative, double bond, like this. And further, that is hydrolysis there. Okay, if we're using this H positive and OH negative, and so be noted it's nothing, it's a basic hydrolysis. And then again, we're getting a carbon, carbon, this. Okay, this is all for the mechanism. It's really simple that we are using the basic condition for KMNO4 or osmium is there. Attack will be the from the same side, that is a syn addition. This is how the mechanism look like. It's enough. Not more than that. We're going to follow like ma'am, how about the like why how to remove this? Okay, it will simply increase your job. So leave that. This is simple, sorted, and enough for you. Okay. So again, any problem? So Haris, actually I'm not following your NCRT mechanism, you know. We are just checking simply for what G means. Okay, so this is important from the G point of view. Okay, but if you maybe you already know, if you deal with these reactions in the laboratory, so it's one of the famous reactions. This and Brahmin water test, 11th class, practical part, Harish. Okay, anyway, yes, please confirm any problem with this. How to prepare pyridine? Pyridine is no, actually it's already a compound. Okay, it's aromatic compound. You know the same like uh, it's a part of the heterocyclic chemistry. Okay, right now I not remember the reaction. Okay, but let you know in the next class. Okay, Abhishek. But actually it's a simple solvent in a laboratory, so we're directly using there. Okay, no need to prepare this. Now let's see that in the same part. In the first part that we discuss about oxidation part. Okay, so let me just explain. In the preparation part, alkene part is done. Alkene part is done. In the preparation part, now the second is going to be the from carbonyl compound. So from carbonyl compound. If I said this word carbonyl compound, so what do you mean by this word carbonyl compound? You know every CO group. You can say that is OR ester can be there. Okay, you can say carboxylic acid can be there. You can say anhydride can be there. Okay, I hope you know the functional group name. Okay, anhydride can be there, or you can say that is acyl can be there. Okay, or you can use aldehyde as well, or you can use ketone as well. All are the part of the carbonyl family. Okay, all the yes, of course, all the coming reaction now going to be the important part, not for only this chapter but for the carbonyl part as well. Okay, that after this the next chapter is going to be the carboxylic acid. Okay, and ketone and aldehyde, so it's again important for that chapter as well. Okay, so it's a repeated part for the next class you can consider. So now let's start with the preparation from the carbonyl compound. So in this one, actually what we are doing really, okay, you know, I guess you already know the priority order. And in a priority order, okay, in a priority order, which group is having the maximum priority in the complete priority table? Yes, please. Which? Additional water? I'm asking, in the IUPAC nomenclature, in the priority order, which group has a maximum priority? This is my question basically. Carboxylic acid, right? So you can say carboxylic acid is the like you can say that is a hero of the story. So let me just write that. First of all, let's try to understand actually what we are going to do. Okay, we are using some carboxylic acid. Okay, and I want to convert this carboxylic acid into the aldehyde. Let's say so. Can you just tell me from there to there? Option for you, is this reduction or is it oxidation? What is the name of the process? Yes, Neharika. What is the name of this given process? Conversion of acid into the aldehyde. What is the name for this reaction? Like reduction or oxidation? Reduction. It's clearly right. It's a reduction there. Why it's a reduction? Obviously, see this that in this reaction, if you are observing, just focus on this part only. Okay, we are having a two oxygen. But this side we are having only one oxygen. So basically what is it? Loss of electron. You know actually what is really happening, or what is the preparation there from, let me just back again the name, from carbonyl compound reduction. So reduction is the key point here. And now what is the meaning of this word reduction? Reduction means that is the loss of oxygen, or you can say that is a gain of hydrogen. So in this case, hydrogen is same, one hydrogen before the reaction, one hydrogen after the reaction. Okay, cool then. So we can say that the conversion of the acid to the aldehyde is nothing ox reduction either. Yeah, simple. So how to write? That is, it's my nascent hydrogen. It's simply representing reduction process there. Okay. So it's a R C O H. Further, let's go more reduction. So what we are getting, that at the end we are getting alcohols. Okay, we are getting alcohols. Now listen, that if you directly want to convert the acid into the alcohol, so we are going to use a strong reducing agent. Okay, but in this step, okay, like here or here, we can go with the weak reducing agent as well. Why? Because obviously the single step reaction. And now, if I'm using a strong reducing agent, so B noted, like KMnO4 was the strong oxidizing agent in the previous reaction, like same here, the lithium aluminium hydroxide. B noted, like lithium aluminium hydroxide. The name is what? L for lithium, A for aluminium, and H for hydride. Aluminium hydride. So simple, this is the name for this one. Okay, anyway, it's a different thing. So a very strong reducing agent. Okay, this is the point number one. Now the second thing, listen, if you are having aldehyde, if you are having aldehyde, so aldehyde is going to convert into the primary alcohol. Listen, that this is how, because it's a terminal part. Okay, so be noted, if we are starting with aldehyde as a carbonyl compound, at the end we are end up with the primary alcohol. Okay, primary alcohol. Or if let's suppose I am using a ketone. Okay, this is what? It's a ketone there. So what, which kind of alcohol we are getting? You can say it is a O, H and R there. So it's a secondary alcohol. So be noted, if I'm using aldehyde, so we're getting primary alcohol. If I'm using ketone, so we're getting a secondary alcohol. What if, ma'am, we are using acid? Again, if you're using acid, first of all we are going to move toward the aldehyde, and then at that we are done with the primary alcohol. Okay, so it means the, I guess, agenda is very clear. What we are going to do, we are using a carbonyl compound, we are going to reduce them with the help of reducing agent. Now let's discuss about the different method to convert a carbonyl compound into that, this part. Okay, so let's just start with the first one, that from aldehyde we are going to use three things: aldehyde, or ketone, or carboxylic acid. Okay, so from the carbonyl topic, we are going to use aldehyde, and then ketone, and then acid. Okay, or be noted, it's nothing, it's a carboxylic acid. So let me just write, it's a nothing, just a carboxylic acid only. Okay, it's a carboxylic acid. Anyway, let's just start with the very first, that from aldehyde. Okay, so this is the last topic of the class. Okay, from aldehyde. So let me just explain from the aldehyde part. Okay, so in this aldehyde part, let's just start with the preparation number one, that from any kind of reducing agent. Let's just start with like aldehyde and ketone side by side. Okay, let's try to understand. So the step number one. Okay, if let's suppose we are having aldehyde R CO H. This is general reaction. And in this case, I am using reducing agent H2. Okay, it's not require a very strong reducing agent, so you can use H2 simply, or nickel platinum. You know, it's a catalytic hydrogenation. We discussed so many times. Platinum, nickel, platinum simply. Okay, this is a first reagent. Okay, first reagent. Like for a single reaction, we can use different reagents. The reagent number first. It's not step number one. Or in the same reaction, you can use NaBH4. In the same reaction, you can use lithium aluminium hydride. All three we can use. H2, that's normal catalytic hydrogenation, or NaBH4, or lithium aluminum hydroxide. In all three cases, what we are end up simply, that is we are end up with the primary alcohol. Okay, so we are going to get the primary alcohol. Mechanism, no, in this case mechanism is not important, just only remember the reaction simply. Any general reaction? Yes, let's just talk about general reaction. If let's suppose I'm having CH3 and this is a CO and this is a hydrogen. Okay, and then we are getting simply that is OH. Oh, sorry. This is my CH3 and hydrogen and hydrogen. So if you have to write the name, what is it? It's nothing. It's simply a ethanol there. Okay. Now let's start with the ketone there. So same. Now ketone, aldehyde is not that much strong, but ketone is really little bit strong. So in this case, listen, catalytic hydrogenation is a very weak kind of reduction. Okay, and then the second of what? Lithium is strongest one. Sodium borohydride is like intermediate one. So as in this case, again we can use that all three reagent like H2, PD, platinum or nickel. Or the second one, again all three we can use NaBH4, or we can use lithium aluminum hydride. All three we can use. Okay, so let me just write what we are going to get here. That is a secondary alcohol is there. Okay, secondary alcohol is there. What if I want to use the acid? Okay, if you want to use the acid, let's just suppose I'm using this as a carboxylic acid. Okay, carboxylic acid, and I want to stop the reaction here. So I'm repeating my question one more time. My question is what? You are having three reagent H2, PD, platinum or nickel, catalytic hydrogenation, step number 2 or the reagent number 2, NaBH4, or the reagent number 3, lithium aluminum hydroxide. So which one we are going to prefer here? So that we can directly get the alcohol. No, how it is possible ketone can be greater than 2 degree? If you are using word ketone, ketone is always the second degree. I will explain, Abhishek. Just wait for a while, okay? Yes, please. If you are having RCOOH there, so which reagent we have to prefer? Is it NaBH4 or is it lithium aluminum hydroxide or H2PD? Or which one is the like good one? This is my question to you. Yes, please. Okay, so the better one is what lithium aluminum hydroxide. Okay, it's a lithium aluminium hydroxide. So this is done simply. Okay, this is how we are going to follow. Now you ask about ketone. What if it's a tertiary there? Okay, you will tell me, is it possible? Any ketone, any ketone, whatever you like. Let me just write carbon. It is a CH3. It is a CH3 and it's a CH3. Of course, I can't make 3-degree ketone. It's not possible. If we use this word ketone, so obviously the ketone is just 2 degree. Okay, maybe you will like, ma'am, if let's suppose you are having, okay, maybe you are saying like this. Now, still that observe the carbon connected here. So like it's kind of impossible thing. Okay, Bishek, that ketone can't be 3 degree. Are you getting? Yes, it's not applicable for a 3 degree. You are right, Abhishek. Okay, for the third 3 degree, we are going to use the Grignard reason. Just wait for some time. Okay, so this is a simple method that is simply by using a reducing agent. All three are the reducing agent. You can use any reducing agent. Okay, then now, and even you can use so many. Okay, let me just give you some more kind of reducing agent. That if you are having RCOH, okay, wait, let's add there. Where's the aldehyde one? Okay, this is the aldehyde, right? So you can use different kind of reagent, and every reagent is super important. So in this case, you can use NaETOH. This is also a reducing agent, okay? Or you can use BH3. Okay, we just discussed BH3 and THF. Okay, don't say ma'am, mechanism is different. Yeah, I know mechanism is different again. Okay, so you can use aldehyde or ketone both for these two cases. Okay, let me highlight this. These two steps you can use for aldehyde or you can use for ketone. Both are applicable for this step. Okay, same answer will remain same like ketone, tertiary or sorry secondary or aldehyde is this become primary. Okay, so I hope it's enough for today's class, right? I guess so much time already. Okay, now listen. In the next class, we're going to continue with this further. Carbonyl compound, Grignard reagent we are going to use, and some naming reaction like Raymond-Timon reaction, Doe processes. Okay, so that's it. Today's class, it's okay, okay? I guess because if we will continue, so I guess it's boring, right? Anyway, any problem with the today's class? Of course, okay. Let me just write separately, okay? Maybe you are having a problem. Let me just erase this. First focus on this and the ketone slide. Yes. This one or one more. Okay. I hope you're getting Darshana now, okay? That is the last two you can use this, okay? Okay, thank you so much everyone for joining the class and please revise the PYQs question. Okay, so that you are try to understand actually what is happening in the class, okay? That's it. This is all from my side. Thanks for joining the class and now you can leave. If you're not having any problem. If you're having any problem, so you can stay. Welcome. Ted. So I hope you're going to end, right? Okay, Darshana. Thank you so much everyone. Thank you so much again. So let's end.